Good morning and welcome to webinar 3 in the Aotearoa Soilborne disease series. My name's Jeff Smith and I'm the technical lead for the agroecology projects in the Aotearoa program. It's my pleasure to introduce this morning's speaker, Dr. Soonie Chng from the Bioeconomy Science Institute Plant and Food Research Group. Soonie is a senior scientist at Plant and Food Research. Over the course of her career, she has worked on different diseases on a wide range of crops, but her research passion lies in disease-host interactions and creating practical and environmentally sustainable management solutions of airborne and soilborne diseases. Soonie has strong connections with New Zealand cropping industries and has collaborated with international peers on research that will benefit and contribute to New Zealand cropping systems. Her research has included natural suppression of takel disease of wheat, crazy roots of greenhouse tomatoes, development of ramularia leaf spot management strategies of barley, control and management of myrtle rust, bioprotection of vegetable diseases, and development of cold-tolerating rhizobia to improve pea production. Soonie enjoys collaborating with plant breeders, delivering cultivars that can be used as one of the tools for combating diseases and reducing chemical inputs. So welcome, Soonie, and we're certainly looking forward to your talk today.
Oh, thank you, Jeff, for the introduction. Now, for Kriti, I should say kia ora, everyone, and thank you for coming to this webinar. I just want to clarify, I am from the Bioeconomy Science Institute, not the Biosecurity Science Institute, but biosecurity is a big part of research done by BSI here. So I've just hit my 23 years anniversary on Tuesday, and yeah, I survived that long. So today I'm just going to share with you what lives beneath your crops and giving you some examples on how to manage them. I hope the majority of you here today have actually listened to the first webinar given by Lynn, as well as the one previously given by Manjula. So let's get into it. Can I have the next slide, please? Right. If you have attended the first webinar given by Lynn, you would have he would have touched on the different types of soilborne diseases caused by the different kind of pathogens. I'm just putting up this slide to show you, or even to remind you, the kind of damages that you could see caused by the soilborne pathogens on the fruit, on the canopy, and the impact could be quite huge. Next, please. Right. So soil-borne diseases, there are major limitations to crop production, and we all know that. I hopefully some of you here could be are actually growers yourselves, and you would have seen the impact caused by the different groups of organisms that are so inhabiting in the soil and causing all these diseases with the symptoms above ground. Giving the symptoms above ground. And Lynn would have touched on quite a big chunk of that, so I won't go into too much detail. But what I want to emphasize today is that why are they so difficult to control, even with conventional strategies? Now, that's because a lot of the pathogens or organisms could actually form different kind of structures, and they actually survive and persist for a long period in the soil. They can produce structures that survive on host residue and or even in the soil overwintering. And some of them would have spores that will produce spores or release airborne spores that could be dispersed by the wind as well, and also as well to some degree by rain. So that's why it makes them quite difficult to control at times, the pathogens. The other thing is that there are also alternate hosts that are available that could be in the surrounding paddocks or fields, and they can act as green bridges to spread the disease. And one good example is takel of wheat. Takel of wheat, you can find they could also infect couch, twitch, ryegrass, prairie grass, you name it. Quite a lot of alternate grass hosts are actually susceptible to the pathogen as well. Now, chemical control is possible. However, if you want to use a large amount of chemicals to control a big area of soil, that make it not very feasible. Now, soil fumigation is an option, but I'll touch on that later on. But just going to just a bit of a background on this at the moment. However, if you want to use chemicals to control soil-borne pathogens, you could just have to take into consideration about maximum residue limits, especially for your export crops. I mean, not only export, but also for your the crops that are for our local markets. The other thing is making sure that the products are being registered, or there might be products that you are allowed to use off-label as well. And please follow the MPI. MPI has got a guideline on what kind of products can be used off-label, and how do you take the steps to consider them. Next slide, please. Oh, geez. Okay, good. So this slide is put up to understand how disease develop. So we pathologists, or in fact, it's very fundamental information on how diseases are developed, and this is called the disease triangle. The three key components for disease to develop, even this disease also applies to human diseases, it's the same thing. We need the first factor just above that triangle there is a susceptible host. And then on the left, should I say your left? Yes, is the pathogen, the presence of the pathogen. And then you have the environmental conditions that make it conducive for the pathogen to multiply and also infect the host. So without one of these factors, it wouldn't work. Apart from that, you have to understand that different host crops will be susceptible to different groups of soil inhabiting pathogens as well. However, there are research that show that some pathogens actually can infect multiple hosts. So it's not just one particular host. Like for instance, Fusarium might be specific to some host. However, there are Fusarium species like Oxysporum that could affect multiple hosts as well. The next is the amount of pathogen inoculum present in the soil. Now that really largely depends on the site history, cropping histories, and what your neighbors are growing next to your paddocks. Because like I say earlier on, some pathogens can produce structures that could be carried by wind and spread by wind. Of course, there's this factor of human-assisted spread as well. So sanitation could be a big part of controlling soil-borne disease, could play a big part of controlling soil-borne diseases. The other thing is, if you have all these factors or all these components present, and then what you're bound to get a bad disease here, and that's for sure. Now, looking back at this disease triangle, we can't really do too much to control the environment unless it is a glasshouse crop or undercover protected crops. Or if you have a rain shelter, that's a different story. We can't really control the environmental conditions. Now, you could use disease resistance or tolerance varieties, but that's only dependent on their availability. And I know many growers can't or make decisions on the kind of varieties you grow, because that is largely dictated by the needs of the variety and what's needed for export, and as well for it really dictates by the market demand. So what we can look at targeting is, can we look at killing or reducing the inoculum load in the soil? And that's the aim that we try to target when we look at controlling soil-borne diseases. That's the number one attribute that we will be considering. Next slide, please. Right, I'm just giving you one good example here of how that disease triangle applies. So this is, I'm using this as an example mainly because I've got all the pictures. So taker of wheat is is caused by a soil-borne fungus, Gamenomyces triticide, and this fungus has got a wide range of temperatures, optimal conditions for it to survive and infect the plant roots. So in the presence of the pathogen and the susceptible variety, wheat variety, and the soil conditions at the temperature of around 5 to 15 degrees Celsius, that's quite a wide temperature range. So you can imagine this fungus, this pathogen can actually continuously infecting the root systems for over the whole season. So that's what happened. And when you have all these components present, and what we get is these disease symptoms appear on the crop called whiteheads. That is like an early maturing of the plants, and however those whiteheads are actually empty. They do not have a lot of grains in them. Now I have seen personally of a site or of a field that was so badly hit by this soilborne disease that about 60 to 70% of the crop were completely covered with these whiteheads. So the kind of impact on you and on the income of the growers is quite huge. Next, please. There's a bit of delay. All right. So managing soilborne diseases, I put this slide together to just to take you through the steps that you need to know before you think about or consider managing soilborne diseases. The first thing that you must know is know the disease. So that has a lot to do with the diagnosis and identification. And I know that there's a diagnostic labs available that you could go to, or if some of you will be so experienced that you will be able to identify the disease, there are crop consultants that you can talk to, or even some scientists. I do get asked sometimes, but we're not a diagnosis laboratory or research company, but sometimes I do provide a little bit of support if it's related to a project or related to a research program. But what I mean is there are people around that could help you to identify and diagnose the disease. I know Mark Braithwaite, Plant Diagnostics, does a lot of that. So that's one key place to go to. Now, the next thing is to understand your pathogen. Now, why do we need to understand the pathogen? Because like taking Takeogamnomyces as an instance, it has primary infection, and when does it start, and then it's got secondary infection and tertiary infection. So you need to know the disease, the pathogen, and how it life cycle goes. Now Phytophthora is the same thing. How the life cycle goes, and that is a very complex pathogen as well, because of the many spore structures, or not spore but structures that it form. The reason that you need to know your disease, know your pathogen, and as well as knowing your crop is so that it will allow you to understand or identify the window of opportunities to intercept, to manage your disease in the crop season. Now you also must know which part of the crop you want to protect. Are you protecting the fruit? Are you protecting the leaves? Or are you protecting the tubers? This is something that you need to identify, and that those three factors together, it helps you to decide when do you put on your spray or your product to control the disease. Some diseases like Phytophthora, you really have to go in early. You can't just wait till you see the symptoms on the crop. That's always too late. Soilborne diseases doesn't quite work like the airborne diseases. If you see, let's say, airborne diseases, for instance, if you see rust on your crop, and if 5% of your crop are infected, you can sort of make a decision, let's spray, or powdery mildew is the same thing. But soilborne disease is not the same. By the time you see the symptoms, sometimes it's too late. So what's available for use is the next factor that has to be taken into consideration, whether there are resistant varieties available, and then the kind of chemicals, biological or natural products that have been registered for your crops and for the intended pathogens or diseases that you like to target. I know that biostimulants are increasingly getting a lot of tractions, and some biostimulants, although may not be registered as a fungicide or biopesticide, they can provide some sort of control to diseases, and some of them may promote growth to offset the disease infection part of the plants. So that's how they could could be used to integrate into the management. Now, understanding the mode of actions and the active ingredients are quite critical because you have to plan your spray programs quite strategically, while depending on maximum residue limit that's been allowed on your crops. So where do you start? Again, like I mentioned earlier on, for soil-borne disease control, if you know the history of your paddocks, of your field, that you've seen the disease before, you need to make a decision. Do I grow the crop in the same field or I go to a different field? Now, you can also start off with risk prediction. Now, I'm not too sure, but I know some organizations here are offering their detection of the inoculum load in the soil. So it gives you some idea of whether your field is of risk to the diseases or not. Now, there's like SADI in Australia, South Australian root testing. They're also providing some sort of qPCR test diagnostic tests to support if that's needed. The other a lot of growers or many in fact not just the vegetable industry, the cereal industry as well, it always starts off with seed treatment to protect the seed and to ensure that we have a good crop establishment, and that usually start off with seed treatment. Potatoes, you could start off with the in-furrow treatment and during planting. And next one is fumigation. I promise you, I'll touch on fumigation. Fumigation is a complex one to me, mainly because even if you use fumigation, you have to ensure that your crop is of high value to use this technology. Otherwise, it's not sustainable for your financial income. Something to consider. I'm not saying fumigation is not good. This is what I'm saying. The other main point is that you must ensure that beneficiaries are present even after treatment, because there are many beneficial microbes in the soil that could actually act as a barrier to help protect the root system from getting infected as well. There are, of course, other technologies, but I won't touch on too much of that because I'm just wanting to mention them. Now, the ultimate aim is that could we provide some sort of long-term protection to depleting the amount of that soil inoculum, pathogen inoculum. And to do that, in fact, crop rotation is the only effective method, has been proven scientifically and have shown to work really well with reducing the inoculum. And it's not just for depleting soil inoculum, it's also maintaining generic soil health as well and our whole ecosystems. So really, to manage soil-borne diseases, we have to look at the whole system approach, or take a whole system approach in your crop production. Next slide, please. I just have to apologize for my croaky voice. I just recovered from a bad flu. Okay, so some of you, if you have attended the first webinar, you might have seen a similar diagram put up by Lane. I actually didn't attend his webinar because I was sick at the time, but I only just found out yesterday that there was a similar diagram. However, it doesn't matter because it's based on the principles, the 8 factors or principles that related to plant health. Now, looking at that, I mean, my take is slightly different from Lane. He was giving you an overarching and generic overview, but what I want to focus on is taking soil-borne pathogens as a focus. So we start off with that circle diseases on the top there, and I like to focus on soil-borne pathogens. Now, to manage soil-borne pathogens, you could look at, then we move down on the right, down the circles, using plant genetics, resistance and tolerance varieties if they're available, and then nutrition. Now, nutrition have been shown to manage some soil-borne pathogens, but that you have to be very careful with that in managing that Goldilocks effect, meaning you have to use just the right amount. And what's the right amount? And you do your soil test? And yes, there are tools available for understanding that nutritional profile in your soil before you sow your crop or plant your crop. The next is pesticides. Now, make sure that we rotate and strategic use of the active ingredients. I wouldn't re-emphasizing that, but knowing what's registered and seed treatments and what's allowed for your crop, how many SDHI if you're using that as a seed treatment per season. That's something that you want to start thinking about, because some of these, because it's not my focus today to talk about the different groups of fungicides, but you I'm hoping that there might be another seminar on right pesticide use, but that can be considered later. But you just need to take into consideration and understanding the active ingredients and what to use and what not to use and how to use them right. That's all I'm saying. Insect pests are here. We look at controlling insect pests. I'm not focusing on beneficiaries. I'm talking about insect pests that could sometimes vector the spread of the fungi, bacteria, and viruses, and that's where they come in. They could carry fungus spores on their body, and then they land on the plants or on the soil, and that's how they spread the pathogens around in the paddocks and fields. Alternate host weed controls is an important component of controlling soil-borne diseases. That's only when these weeds that are in the surrounding fields or paddocks are actually alternate hosts to the pathogens, the soil-borne pathogens especially. Environment is something I can't control. However, if the environmental factors are correct, conducive, then you get, soil-borne disease or soil-borne pathogens being activated, and they start multiplying and infecting the host, or whether it's below, it could be below ground, it could be above ground. Now, one thing I was going to emphasize was the soil condition. Now, soil condition is something also quite interesting, because a lot of the soil-borne pathogens, like I said earlier on, they survive in the soil. But depending on the pathogens, for instance, Phytophthora it's not a true fungus, but it knows to produce spores or zoospores that swim in water. So if your soil is not very well drained and doesn't have good drainage, and also if there's a bad season of or a series of rain events, there's a likelihood that you'll get Phytophthora developing in the ground more often, more so than others. And a lot of the fungal pathogens actually require that drying and wetting cycles of the soil to help it take off as well. Soil biology is the next thing that I like to touch on, because we talk a lot about soil microbiome. Now, because many microorganisms in the soil are actually beneficiaries, so maintaining that buffer and balance to help and ensuring or maintaining a general soil health is quite critical. That's what I just want to touch on. Can I have the next slide, please? Right. This diagram has been created and modified by me, but it's created by our graphic designer. It's nice. 4-step rotation, crop rotation is I feel that this might be a system that will work quite well in New Zealand conditions, given that, like for instance, in the South Island, we have cereal always in the rotation system, and then in the North Island, we will have leafy veggies together with maize as well in the rotation system. So this 4-step crop rotation system may work really well in New Zealand. So we can start off with legumes. Let's start off with the bottom left there with legumes. I just listed a few examples there, and then move on to our leafy crops, lettuce, brassicas, broccoli, etc., and then to tomatoes, our fruit crops or cereal. Now this is or cereal, fruit crop, pumpkin, squash, tomatoes, and then to the root, tuber, and bulb crops. If you notice that when we start off with legume, they're the nitrogen fixing crops, and then moving on to the leafy veggies, leafy crops, they are the nitrogen hungry crops, and then the fruit, cereal, and the phosphorus and potassium, of course they need nitrogen as well, but from what I've seen, I think we have plenty of nitrogen in our ground. Whether they are available to the crops is a separate story, but they do need phosphorus and potassium as well, all those crops. Now this rotation system, I think I know sometimes we are limited with the rotation that we're practicing in our our crop production system or by growers, because it's just dictated by what is needed by, for instance, by the processing companies. And so, or from, I can't decide for you, but this is a good strategy to manage and looking at reducing that soil-borne inoculum, the quantity of that and the concentration and amount of it in each field. And that's what we try to aim. I did not put maize on the maize and pasture, but that will be where the fruit and cereal seed, and maize and pasture should go into that for the South Island growers. Now and also for North Island, maize is in that system as well. Now I have a hate-love relationship with maize. I like maize. It's important it's an important crop. But maize is very well known of carrying lots of the pathogens, even though they do not do any harm to maize themselves, but they are good at harboring those pathogens. And if you have crops there, and this is particularly true for Fusarium species. Now, if you have a crop that is susceptible to Fusarium, and you know that Fusarium some of them can affect multiple hosts, sometimes you might get a bit of an outbreak of Fusarium passing on from maize to your following subsequent crops. And that's why I have this relationship. I feel like I like maize, but where do you put maize? But if you really need to grow maize, put it under fruit and cereal. And then if you choose your crop wisely, like if you grow potatoes or something else, you shouldn't be too affected by the Fusarium carried by the maize. So next, please. Right. I just want to touch on, because I've been told to give some examples from the Alive to Touch project that I've been leading. So back in 2022, we started this project, this multi-year project under the Alive to Touch program. This project was co-designed by Processed Veg, Kraft Heinz at the time, and BSI Plant and Food Research Group. And until recently, McCain has come on board in the last season. The whole project aims to investigate the potential of some biofungicides, biostimulants for their efficacies against Fusarium root rot of peas and Sclerotinia of beans. The overarching objective was to identify effective options for disease management and to some extent provide data to support label change or registration of the biological products or options. Now, the project started off with the industry, the processed vegetables industry actually do not have many products to use on their crops, mainly because of the diminishing, or the active ingredients get taken off the market, or there just aren't any or many that are allowed for the overseas market because of the maximum residue limit requirement from the overseas countries. So next, please. So this project was started for that reason. Okay, just a bit of background on the disease. So I touched on different diseases earlier, but Fusarium root rot here is caused by a soil-borne Fusarium complex that inhabit in the soil. The three main species are Fusarium solani, Fusarium avineasium, and Oxysporum. Now, Fusarium avineasium is more common in the South Island, mainly because of cereal in the rotation system. Now for Fusarium solani is specific for peas, and Fusarium oxysporum is across all, in fact, many crops. It's actually in both North and South Islands. Now the kind of yield impact we're looking at is about 10 to 30% yield reduction if nothing is done, and you have a bad disease here, and that is what happened. The next one is Sclerotinia white mold. Sclerotinia is caused by, there are three types that may cause Sclerotinia, but we have done some survey in this project, and we found that Sclerotinia sclerotium and Sclerotinia minor are the two major pathogens that are the causal agents of Sclerotinia on beans in New Zealand. The kind of impact that we're looking at is about 10 to 15% pot yield reduction plus post-harvest damage. And I believe that I'm sure most of you would have seen that happening as well. We would have bought a packet of beans from the supermarket, and within a week or so, and you see a lot of mold, it gone moldy and rotten, and that's the culprit is actually Sclerotinia. Now, the next one is that this particular pathogen form different kind of spore structures that survive in the ground for a long time. They produce these mushroom-like structures. If the weather conditions is right, release hundreds and thousands of spores, and they can land on any plant parts and infect the plants. The other thing is when the mycelium or those kind of white moldy structures that affect the plant parts as well. The other thing is that they form these black fruiting bodies called sclerotia, and this kind of sclerotia can survive in the soil for more than 10 years or even up to 25 years. I've seen some record. So they look like red droppings. Thank you. Next slide, please. So Sclerotinia itself is a very difficult to manage disease. So we done a few we set up some field trials over the last 3 years or seasons. In year 1 and 3 of the project, we have both pea and bean trials in Canterbury. And in year 3, we set up actually an additional bean trial in Hawke's Bay. We were going to set up the bean trial in Hawke's Bay in year 2, but because of the Cyclone Gabriel, many sites were flooded. We couldn't do that. For that reason, that's why we did the pea and bean trials in Canterbury. The sites that we selected for the trials were of risk to the two diseases, either because historically we knew that they had Sclerotinia and Fusarium root rot, and also because we did some pre-sowing diagnosis using qPCR and counting the sclerotia in the soil. Next, please. So the progression of the number of products or product combination with screen, we started off for the peas, controlling Fusarium root rot. For the peas, we started off with 19 product combinations, and they were compared to, some of them were actually synthetic, and some of them were biostimulants. And we compare all these products against a non-treated and a standard synthetic product that is registered and allowed for the crop to control the disease. And for beans, we started off with 14. And in year 2, those were narrowed down to 14 each. And of course, we added some additional products that came along in that second year screening process. And in year 3, which was the season just been, it was narrowed down to 5. And 4 for beans. So next, please. I'm just going to focus on the results from year 3. So application timings for the peas, the products were, like I said earlier on, what do you want to target? The soil, the seed for establishment, and also earlier on in the crops cycle or crop season. So for peas, the products were either applied onto the seed or sprayed onto the base of the plants onto the soil post crop emergence. Now they were applied either individually or they were treated in combinations, in the sense that the crop for one of the treatment was receiving both seed treatment and also the post-emergent spray. For beans, we had one product that was incorporated in the soil before sowing, and then we had pre-row closure application, pre-flowering and mid-flowering, and also the combination of pre-row closure, pre-flowering and mid-flowering applications. And we have a picture with my colleague Shane Maley doing the post-emergent spray to the pea trial. Thank you. Next slide, please. We measured the severity for Fusarium root rot on the pea trial at mid-flowering, and then of course, we measured the yield component or components, the different yield components of the plants during harvest. And the same thing was done for the Sclerotinia white mold. We also scored the mold severity in the field and on both on the pods, because that's the cell component, that's the yield component of beans. We actually, for all the bean trials, we set up weather stations because we want to understand, like I mentioned earlier, and how to know the disease, how to know the pathogen. So that's why we had weather stations set up for both North and South Island at the bean trial sites. The pictures here show the kind of symptoms that we score, and we have developed that rating scale, particularly for this project on the beans as well. Next slide, please. So again, just focusing on year 3 results. So if you could recall, I mentioned earlier on, we screened 5 product combinations. So this graph just shows when we compare to the untreated treatment, what are we seeing? What's the effect on of the products on the root rot severity from each treatment? Now, the left-hand side shows all the products that we apply compared to Wakil, which is a standard fungicide, synthetic fungicide that we're comparing as a seed treatment. But what I want to emphasize is that all these products are recorded, are coded, mainly because a lot of them are not registered or they are off-label. So they need to, we need to be very cautious with that at this stage for this time of the project. So it's just for that. So what we have found was that all the products that we screened in the last season that just been actually reduced root rot severity by 6 to 13%. So that's quite good one. I need to go through quite quickly. I don't want to take up too much of your time. Next slide, please. And then next we move on to marketable pea fresh yields, and that's the one that the growers want to know, and everyone wants to know how that impact on my yield. Now, we didn't have a very good yielding year for the pea last season. However, despite of that, we were still able to see a good effect on the product given by the products. So mean marketable fresh pea yield range between 6.8 to 8.5 tons in the last season. In comparison to year 1 and 2, we had like up to 12 tons per hectare, but last season was because of that continuous or succession of wet events or rain events that we had in the season, and so that's why it affected the yield quite a bit. Now, on average, yield increased by 0.58 to 1.64 tons per hectare by the products, and we're looking at about 8.5 to 24% of yield increase. So the impact is still there, and it's huge with all the products that we've tested. So the graph on the right-hand side, I should mention that when we compare to untreated, which is the dotted line in the middle there, on vertical dotted line, anything that fall on the right hand side is an increase. Anything that falls on the left hand side of that line is a decrease. So what we saw here was that the yield increase, all the products increase the yield. So that's great. Next slide, please. One thing quite critical is that we have noticed over the last 3 seasons from all the bean trials that we've done so far, that infection of Sclerotinia white mold actually happen on flowers during reproductive stage. And that is very critical. In the past, we could only see white mold forming on the plants when the beans already forming on the plant or already formed on the plant. So to this, you can't really see that infection happening with your naked eyes. What we did was we actually collected the flowers to the lab and saw a lot of mold growing out of them. So we knew this is critical for us that the infection actually happened on flowers during that stage. I have noticed, at the time that some flowers were being aborted on the plants, and that could be also part of the reasons because of the infection happening on the petals. Now, the other plant parts, when it becomes more apparent, like getting like the picture on the bottom there, we're looking at about 6 to 9 days before harvest, and depending, of course, on the weather conditions. Now, we've observed this over the last 3 seasons, so this information is actually quite critical for disease management. The next one is in generally field severity differed between North and South Islands, and that is also dictated largely by the planting and row distances used by the machine or the drill. So we can't really affect that, but at least it gives us some information that maybe keeping the row distance a bit bigger will actually reduce the infection from happening. But that is also depending on largely on weather conditions as well. Now, there's generally lower severity in the Hawke's Bay trial in the last season. Okay, thank you. Next slide, please. Now, looking at the pods, which are the most critical part, that's the yield component that the growers or the industry is selling. We score the Sclerotinia severity on the pods. In general, the disease pressure was low for Sclerotinia last season. It's like Murphy's Law. The previous 2 seasons we had really bad Sclerotinia in Canterbury, but last season it's a wonderful season for beans, not so good for peas, for the later sowing peas, but that's what happened. That's just the way it is when you deal with field trials outdoor. So what we found was that the disease severity ranged between 3.9 to 6.7 and varied between the 2 sites. Okay, next. The other thing is I've got the keys there for the different coding. Is the way of when the product was applied. So the same color scheme it carries over to these figures here. So again, this is when we compare with the untreated standard or control. What we found was that 4 out of 5 treatments in Canterbury for the Canterbury trial reduced Sclerotinia on pods. We're looking at 1.5 to 4.3% reduction. For the Hawke's Bay, 3 out of 5 treatments reduced the Sclerotinia on pods, looking at 0.7 to 2.8%, again because the disease pressure wasn't quite there. Now, for the Hawke's Bay trial especially, and that might be masking the effect. But we did notice that because of the weather and the microclimates variation between the 2 islands, this might be something to consider later on if we apply natural products, biological products, mainly because they're living organisms, they survive or behave differently between the 2 islands. So there was one particular product that was incorporated in the soy P14, which is the pink color on the graphs there. They actually reduced severity in both trials quite consistently in both Canterbury and Hawke's Bay. Next slide, please. One thing we have done, this is something that scientists do. We actually check the post-harvest sclerotia count and viability for just the trial in Canterbury in the soy. What we found was that all the products, or including the untreated, the sclerotia count in the soy post-harvest actually reduced. And this is no surprise because the residue or the fungal structures of sclerotia on the residue haven't gone back into the soil yet. But for some, but we still wanted to know what the different products were doing to the sclerotia, especially not just the count, the population, and as well as their viability. So we took some after counting, and we selected some of the sclerotia and try and germinate them and see whether they remain viable. So what we found was that all the products that we tested reduced the population of that sclerotia count in the soil, and some of them them even up to 75%. So one of them is the P14, the soil incorporated products. And interestingly, not all the products would make the sclerotia non-viable. All right. The pristine is a standard product or synthetic that we compare all the products against, and that actually kill all the sclerotia that we tested. And for the rest of the products, they are quite variable. But this is something that we can consider when we look at using the product. So the inoculum is there. We reduce the inoculum in the soil. Are we able to kill them? Some of them yes, some of them no. So the kind of consideration later on when we want to plan our spray program, this will need to be considered as well. Next, please. Okay. Oh, I don't know what's wrong with the slide. Are you guys seeing like what I'm seeing? Because that's strange. I didn't prepare them like that to cover the headings, but this is looking at marketable pot yield. So generally, it's a high yielding season. In Canterbury, each plot was producing 25 to 29 tons of beans or pots per hectare, and that's quite huge. And of those, 99% were of marketable quality. We didn't see a lot of the damage diseases or the damage blemishes or lesions on the pots. In Hawke's Bay, on average, about producing around 24 to 27 tons per hectare of beans, and of those, 91 to 95% were of marketable quality. Now, the untreated plots or on average produce around 89% marketable pots. So it's not as high as the ones that have been treated. So no matter what, treating the plants is still at least increase that yield in general compared to the untreated. Next slide, please. When we look at the marketable pot yield in Canterbury, 3 out of 5 products actually increased the pot yield by about 0.1 to 1.7%. For Hawke's Bay, 4 out of the 5 products increased pot yield. It doesn't mean that those products were ineffective in Canterbury. It just means that some of the products might get established and behave slightly better in North Island conditions. And that will be up to the product suppliers to think about, how the dose recommendation and such. So we can, that's the further down the track for the research to address. Again, looking at the two figures here on the right are the one that increase. So the key messages is that from this project is that many products actually reduce the disease severity and increase marketable yield. Sorry, that's going really fast. Sorry, I'll move on. Next slide, please. So was that most of them, many of them, we have a lot of potential products that could look at reducing the two diseases and increase marketable P and pot use. And performance of some of these products actually have been quite consistent. Like one of the product that was applied onto the seed actually consistently gave about 10% reduction of root rot severity, things like that. And even the soil incorporated product was very consistent as well in its performance. Now, like I said earlier on, the conditions differ between the two islands. So we have to start thinking about product establishment and whether the dose of application need to be changed and timing of applications. Now, sclerotinia, wet conditions, 16-hour leaf wetness before and during flowering at 10 to 15 degrees Celsius will encourage the disease. So this is the time of the window of opportunities, understanding when to apply products to control the disease. Infection consistently started at flowering on beans for sclerotinia. So we can use this information to look at designing or redesigning critical timings for spray program with synthetic and natural extracts or even biological products to targeting at pre and mid flowering, because we want to protect the flowers. What we want is good looking and huge, well, I don't know how that huge they will be, but bean pots that we want to protect. This is what I'm trying to say. But one thing to re-emphasize is that there's no silver bullet to everything. There are different. We have to start thinking about, maybe the product suppliers have to start thinking about, do we need different ways of applying the product? Because how we apply the products in this project really dependent on what the product suppliers told us how we could apply their products, our best way of delivering them. So maybe there's a different ways or better way of delivering the products to the ground. Now, we need to start thinking about a system-based approach to get the product established in the soil and long-term kind of protection. Now, my idea is that not only using those products that are targeting particular diseases, also start thinking about integrating crop rotation into the system as well. So next slide, please. So where to from here? We are planning setting up field trials as well as demonstration trials in both North and South Islands in the coming season. We like to narrow the list down or not for the products used in the next season. We currently are completing a qPCR survey of Fusarium root rot and Sclerotinia white mold in Hawke's Bay. Hopefully that will give us some information on the extent of the problems in Hawke's Bay region, as well as giving us some indication on what are the sites that we should go to for the trials and the demonstration sites. The ultimate outcome is that we can co-design a management strategy which integrates products that work in combination, control disease, and promote crop yield into our current production system. But it's critical to understand that, products that we have to understand whether they're compatible with the current synthetic products as well. Now, finally, I'd like to also acknowledge that there's a huge team of people involved in this particular project at Plant and Food Research. We started off, or BSI Plant and Food, we started off with a team of about 5 or 6, and now the team has grown to about 17. And I also like to thank the growers for participating in the trial, and especially to the processing companies for products and site selections. One person I like to really thank is Najo at Wardy's. Thank you very much for your patience.
That's fantastic. Thank you, Soonie. We've got a few questions there, and apologies, I omitted to mention at the start to use the Q&A function on the webinar if you've got some questions. So it is open now. We have got a few come through already, and I might start with some of the recent ones that were pertinent to the processed vegetables project. So firstly from Stephen, while it appears yields increased and some disease suppression was achieved, it also appears very few. None of the results were statistically significant compared to the untreated control.
This is using the analysis of the results were done by using the R package. So it's not quite the same as looking at statistical difference. We were looking at effect size of the different treatments. So if I have a statistician to answer you the question, that would be a much better person to address this. But our statistician who's on this project used our package to analyze our data. And it wasn't, the reason we were using the same thing is because we started off with 19 product and product combinations. So we had to carry that through for our trials throughout the whole project. The similar way of analyzing the data to keep it consistent. Hopefully that makes, yeah.
Can you just clarify and do you know what crops preceded the pea and bean trial sites?
Cereal, I believe. Sometimes cereal, yeah. But because I'm not sharing a lot of information on what we found with the qPCR test and other things, but I believe was cereal, because though in the South Island it was mostly the Canterbury region, cereal was in the rotation. Sometimes it's never been peas and peas. That's what I've known. Yeah.
Okay, cool. Thank you. Chandon asks, can you please share your view on the impact of fumigations on pathogens in the seeds and roots, as well as the viability of seeds or roots or budwood if we grow plants from them?
I can't because I haven't done any research on fumigation, but I've spoken to the representative from the fumigation companies, one of them especially, and they have shown me some research they've done in-house to show that some of the beneficial microbes, like for instance, this is me talking about, for instance, trichoderma, the population actually went up. However, I don't know whether the trichoderma species in the soil was the beneficial type, because we never know. Some beneficial microbes might be actually pathogenic, some of them are beneficial. So in particular, I have no idea. So it depends on the dose of the fumigation. And I think if research have shown, or they've done a lot of research or data, they have data to show that it works, and then it's all right. But fumigation, make the soil really clean, and it could be I like to use the term suction. It can act as a base to suck whatever things that can get established in there. So things that will survive fumigation will work on there, will survive in the soil post fumigation. So they might be resistant to the, let's say, chlorpyrifos that was used in the fumigation process. Now, I don't, again, what is allowed on your crop? This is something I don't know whether crop residue limit, the residue of chlorpyrifos on the crop has been tested or not. So, but this is up to the fumigation company to look into that. I hope that answers your question. That's my view. Personally, I don't encourage fumigation, mainly because it's the cost. If you growers or industry feel that fumigation is a way to go and is economically feasible, go for it. But personally, I don't like it, mainly because I shouldn't be so strongly. I shouldn't have such a strong view. Is that it's about considering the microbiome. What are you impacting? The things that are not causing diseases as well. So think about in that area and the environment or soil health in general.
Yeah.
Mm.
So very much akin as to human health. We talk about
Yes, all chemicals have got some effect on human health. I want to emphasize that even if you're putting natural products, that the biological product, even if you're using tea tree oil, let's say, I'm just making an example, you should really protect yourself, because it's not like you're applying a concentrated amount. Yeah.
Okay, thanks, Soonie. There's a couple of questions here on specific pathogens. So the first one is Sclerotinia minor actually Sclerotinia sclerotorium minor?
Yeah. Oh, is it the name? You're talking about the Sclerotinia sclerotium and Sclerotinia.
Yeah, is it actually Sclerotinia
minor? Yeah, Sclerotinia minor, Sclerotinia sclerotium. There's another one, yes, but we didn't see that. We didn't detect the third one in the soil that we surveyed so far.
Okay.
But thanks for that. I just couldn't squeeze everything on my slides.
Yeah, sure. And just going back to the maize topic, is maize a host of specific fusariums or all of them?
Many.
Unfortunately,
many, because it's just on the starburs, on the maize starburs. They survive on the maize starburs. Fusarium comorum, Fusarium pseudograminarum, Fusarium oxysporum is the same. A lot of Fusarium can survive on maize.
Yeah. So that has an impact on following crops, I guess.
Yes. That's why I say in your crop rotation, you have to plan it quite well. Even if you want to grow Fusarium, you want to grow maize, and you have to start thinking about, with my crop rotation program or picture that I've shown earlier on, what's on that list that you could look at and shouldn't, if you're targeting at Fusarium, what should you grow? Potatoes might be less likely to be infected by Fusarium. That's what I'm thinking. Yeah, but I don't want to say take out maize completely, because that's not possible for our North Island growers. You see where I'm coming from? It's not possible because
Yeah.
maize plays an important role for the North Island dairy industries and also for the growers.
What about the scenario where maize is grown for grain and it's maize on maize on maize, continuous maize crops? How does that change the outcome?
Or you don't have a
rotation?
susceptible crop, you just go long-term maize. The outcome is that what are you doing to that soil? It's not just on the soil-borne pathogens, but yeah, you can try that, but is it good for the soil health? You can. I haven't seen that. Someone please let me know and let us do some microbiome analysis if there's a need and there's a potential there's a opportunity for that. I haven't heard who has long-term maize in New Zealand. I'd like to know.
Well, I think the grain growers do.
The grain growers do, yeah. So that would be good. I mean, it's fine. They don't have other vegetables or other crops in their system. They're not practicing crop rotation. They just want long-term maize.
That's right.
I just want to give one example, like for instance, the cereal, wheat. If you grow wheat long term, you can get to this stage when you have a disease suppressive soil.
Yeah, sure. Question from Prannoy. What's your thoughts on having mustard brassica as cover crops near affected crops? These can release glucosinolates, often known for a biofumigant effect in soils. Has there been focus on investigating this, please?
I believe this was done in a separate program with a separate project within the Aotearoa program. Is that correct? This has been done now.
But in the squash project, perhaps?
Yeah, in the squash project, yeah. So I don't know what's the outcome they found, but what I want to talk about is that if you're using mustards and was it mustards and what's the other one?
Brassicas in general, yeah.
Yeah. Now consider them in that crop rotation cycle as the leafy crops. Put them under that leafy crops. All right. Now I know they release their chemicals, and some research have shown that they do release, but that they're chemicals to help manage soil-borne pathogens, but it also largely dependent on how fast the residue gets broken down on the site in the soil. So this is what I've seen, that research have shown that it really depends on how fast that residue breaks down. And then you start thinking about, should we start introducing microbes that will break down the residue really quick? It could be a win-win situation. You have that product that you could put that on to help your residue break down really fast to release that chemical. It might be a potential, but possible. Yeah.
Okay. Well, that's an interesting aspect, yeah. Another one from Prannoy. Would increasing the beneficial soil microbes help in controlling, suppressing soil-borne diseases? There
are some microbes that are known and well known because a lot of research been done, especially microbes that produce, they call them antifungal or antimicrobial chemicals. Like for instance, let's say a group of bacteria, Pseudomonas. Pseudomonas produce antibiotics and other they call them. God, my head is blank at the moment, but they do produce some chemicals that would inhibit fungal growth or spore formation. But inhibition is completely different to kill. I just want to make it clear. Inhibition is completely different to kill. So what we want to aim for is killing, not just inhibiting, but also killing the ones that we do not want. That would be a perfect world, wouldn't it? But there are well-known soil inhabiting beneficiaries that will do that. So it could be not just that, it could be other microbes that improve general plant health, not just when I say soil health in general and plant health. We're not talking about just diseases. We could talk about, in general, some microbes are known to improve porosity of the soil structure, therefore improving the drainage. That kind of thing as well.
Great, thanks, Soonie. Another one, would it be safe to say that foliar ferts biostimulants might work by increasing the healthy vegetative growth, thereby giving the plant a better chance to fight off a disease, not specific to soil-borne diseases, but disease management in general?
I can say yes. Then you can't claim that for control of disease. Now, a lot of nutrients, for instance, nitrogen. Let's just give one example. Nitrogen has been known or found to protect or give help control Gamenomyces, which is the takeover of wheat, but it's really just to promote vegetative growth and also the root system as well, root growth. And what they do is that with this additional growth stimulated by the nitrogen or nutrients, it actually offset the parts that have been caused by the disease. So that's the U penalties that have been caused by the diseases. So you can do that. I'm not saying that it's not a bad thing. That's why we have biostimulants in there. Biostimulants can help. If you could offset the U penalties caused by the diseases by applying biostimulants, and the economical impact is not as huge, the investment that you put on your crop production system can offset the fungicides you apply. It's all about making money and protecting the environment. So this is where I'm coming from. Yeah. Does that answer the questions? I hope so.
Oh, that was pretty good for me, so hopefully for Pranay as well. And final question from Namisha. Any studies done on cover crops that can control fusarium? If so, which type of cover crops best suppress fusariums?
I like to know as well. I'm sure there are some. I wouldn't say none, because there are crops that are not susceptible to fusarium. But unfortunately, fusarium is everywhere. You know what I mean? So we have to find out like what are the crops that are not susceptible to fusarium. Knowing the soil as well, what's in the soil. Cover crops, I haven't looked at that. I have to be honest with you. I haven't looked at that, and we have to start looking at the types of cover crops we use in New Zealand, and also start isolating what kind of fusarium is there, finding out what are the fusarium population on their rhizosphere or root system. Then we can then decide. Different kind of cover crops might have different susceptibility, and this kind of thing can be done easily and find out easily in research. So we can talk about that later if there's an opportunity. But at this stage, I have no idea because I haven't looked. But because every host or crop has got different the group of pathogens that they're susceptible to. That's all I can say.
Yep. Yep, sure. And the next webinar on Thursday this week may actually shine a little bit of light on that, where we're looking at the Buttercup Squash project.
Yeah.
And I know they have looked at cover crops to use in that cropping scenario.
Yep.
Where fusariums are a major pathogen of interest. So something to look out for. Look, we're well over time, but thank you, Soonie, for sharing some of your extensive knowledge with us today. Obviously, it's a vast and complex topic, Soilborne disease, so thank you for breaking that down and giving us your insights, particularly on the management angle, which is of interest to our audience particularly. Yeah, so webinar 4 is on Thursday this week, 25th of September, and it will be at 9 o'clock in the morning. The focus will be on future innovations in the diagnosis and disease management. So we look forward to catching you all then. Thank you very much. And thanks again, Soonie.
Thank you.